There's more value in the connections outside of these talks than actually listening to the talks themselves. Like we've spoken to a lot of very experienced, very tenured people who have lots of, great stories and mistakes that we can learn from so that we don't have to make them as well.
How's everybody liking CppCon 2021? Woo! All right, who's exhausted? Yeah. All right, well, I promise to not be too hard on you in this session, hopefully. We're gonna go through what's coming in C++23, and hopefully it'll get you a little bit excited about some of the good stuff that's going to be coming soon. So, just a minute about me. I'm a C++ programmer since 1995. My name is Jeff Garland. I'm part of the Boost community from the very beginning, or from the early times, author of Boost Datetime, and now I'm the assistant library working group chair. So what you're going to see today, I get the pleasure of reading every single one of these papers in all gory detail to try and make sure we get the specification of them exactly right. So if you're watching this on YouTube in 2023, you should look again on YouTube for a better version of this, because by 2023, it'll actually be fully settled. Some of the content that I'm going to talk about today won't end up in C++23 exactly the way I talk about it. Some of it might not end up in C++23 at all. But most of what I'm going to present to you today are things that I think are reasonably likely to show up in C++23. So this talk, wherever possible, I've compiled stuff and put a Godbolt link for you to play with. I'm gonna put a link up at the end of the talk for the slides, and I'm actually going to keep this presentation up to date as we roll toward the end of 2023. So you can use it as a mini reference going forward to look at some of the new features of C++23. Okay. So what's the overall status? It's going to ship on time. This is an immutable thing now. We don't do it any other way. You've probably heard it called the train model. So this is whatever's at the train station when the train leaves goes with the shipping. So there was a plan, which is in the paper that's linked there. An overall plan to focus on things like networking, modules, concurrency, and of course always bug fixes. Bug fixes are a really important part of what we do because the committee's not perfect and we do make mistakes. It's interesting that the must focus stuff didn't really have any language features on it this time. After 3 large language features in C++20. So, and I think what you're going to see with C++23 for the language side is there are some small, nice features, tweaks, but nothing large. So, of course, the pandemic has put a wrench into basically everything, and the C++ committee is very dependent on working face-to-face to work through hard problems and figure out how to do things. And so that's just not possible since February of 2020. Now, if you saw Bjarne's keynote, you know that the Prague meeting was where we basically finished shipped C++20. So effectively, all of C++23 is being developed virtually, which is a very difficult change for the committee. And discussing it with other members of the committee this week, I can say that it's resoundingly the case that we find it really, really difficult to work on hard things. Smaller things are easier and can be done, in Zoom, but you just can't get the same the same focus of people in a room. Okay, so what were the priorities? Yeah, what were the priorities? So we're going to get some of the priorities, but not all of them. We're going to get support for modules. I'm pretty confident of that. But we're also going to get a lot of other things that maybe weren't so obviously on the priority list. Like we're going to get a lot of addition to ranges and some additions to format. So who's using format or FMT library now? Quite a few. Okay. So hopefully you won't have to use it forever because we're going to put some more of the stuff that's in format into the standard. And I'll talk about these. And then there were just a whole list of things that, you know, didn't quite make the train. So here's the outline of my talk. Anybody see any problems? Let's see, how many slides are there? Oh yeah, 102. I didn't ask for enough time, clearly. So cuts have to be made. Oops, sorry. Too many. So I'm going to try and hit upon, you know, the high points that I think, you know, apply to almost every programmer in one way or another. And then I'll probably get a little audience participation a little later. And maybe we can go back to see some of these things. So this is kind of the outline of what I'm going to cover. Some specific things I'm not going to cover. I'm not going to cover execution, generators, MD span, freestanding. I'm sorry, Michael. I apologize. Flat set, flat map. And it's not because these things aren't important. It's just they're relatively large. And I think with things like flat map and flat set, that's pretty well known in the community. You know, you basically just put flat underscore in front of, you know, map, and you know, you'll get basically what you had before. There's some new interfaces and things like that. The top list there is stuff that's still in flight, which means it's not yet done. The bottom two things, the move only function, which is also called any function, those are actually done in the working draft. And that's another thing. As I go through each topic, I will talk a little bit about, you know, what the status of it is relative to the committee. Okay. So there are a few new things in string processing. And why do I lead with string processing? Well, because I think every program I've ever written uses strings pretty much. And I think most programs use strings. So strings turn out to be an incredibly important thing for most programmers. So I'm going to cover the first two. The other two at the bottom are a little bit narrower case, and you can look at the slides and read about it if you want to. Or if we have a little extra time at the end, we can go back. So the simplest thing in the world, right? I just want to know if a string is in another string. That's it, right? And today, what do I have to do? I have to do find. I have to do some ugly code. Well, so starting in C++20, we got you know, ends with and starts with, and now we're going to get contains as well. This is the simplest thing you can imagine. It's kind of a shame it took this long for us to get to the point where we could actually just write this simple code. And this one is already in the working draft. It's one of the first things. It was actually one of those things that we're mopping up from C++20. It should have been in C++20, but it just didn't quite make it. Any ideas what this code does? Anything? What's that? Undefined behavior. Yeah. Well, it terminates in a nasty way. In this case, because I didn't actually, you know, catch the exception. But this is one of those little razor blades of C++ that, you know, you could write this, right? I mean, it's easy to make that mistake if you've got, you know, a return of a null pointer somewhere, and of course it could be 0 as well, right? So it really causes the same problem. So now we're going to break your code in C++23, And basically, we're going to break it in a good way because we're going to give you a compile time diagnostic. This one is also in the working draft, and it's actually already implemented in GCC 12 and some of the other compilers. So, okay, that was an easy start. I'm going to skip those. Let's talk about modules. So, who does not know anything about modules? Everybody knows something. Okay. I'm not going to give you all the details of modules, but the reminder is that it's a big upgrade in the way we actually include things into a translation unit. We're going to have a binary file format that actually will get compiled as part of the compile process instead of what we're doing now, right? Which, if you think about what #include does, it's essentially a cut and paste. So you can imagine I've got 100 files in a translation unit. I'm essentially cutting and pasting 100 files into a translation unit, making the compiler run through every single one of those headers every single time we compile it. So import is the keyword for module access. And what didn't get in 20 is how do we actually get the standard library as a module? Now, there are header modules, which are a special case of modules, and we did get that in C++20, and you can actually play with it in some of the compilers, which basically you take the name of the header and you say #import, and you'll get the header module. So that's one thing you can do right now on some compilers. But is that really what we want to do? Do we really want to continue this current model that we have? So there's a bunch of considerations here to think about. Do we want, how do we want to divide things up? Do we want core, containers, algorithms? There's a bunch of different ideas, that you could do. We could go really granular, and for every single type we have in the standard library, we could have an import. That sounds like a horror show, to me, honestly. But, you have to think about where do we want it. Now, an obvious thing is import std, one big module. And that has some interesting implications. It's certainly super easy to teach and understand. It's also super easy to write a program because you don't have to ever remember where anything is or what the structure of the Byzantine headers of C++ are. So it has a lot of good properties. So what about some other things? What are we actually going to include in modules? Because if from what you know about modules, you know that macros are generally not exported, and there's a finer grain of encapsulation that you can create through modular programming. So what do we want to actually come out of module std if we were to make that choice? Because as it turns out, there's a bunch of things in some of the C headers, for example, that are in the global namespace. And maybe you don't want that in your program. And I think in general, we probably don't want, to have the macros, but then assert, for example, is used in a lot of programs. So there's this tension between ease and what's actually, how easy it is to transition to a modular world versus, the potential collisions and potential issues. All right. So what's the decision? The decision is two modules, one called std and one called std compat. The first one basically gets you all the standard library facilities except for that stuff that's in the global namespace. The .compat is something that if you need to use that stuff. Now, of course, you're thinking to yourself, if I need to use assert or I need to use a feature test macro, I need to have a header because we're not going to export a single macro out of std, which you should be thrilled about this. The macros, have caused a lot of problems over time, and it's really, really good. So, of course, the downside, right, to this whole thing that I've just told you, and you're probably thinking, oh my goodness, how long is it going to take to compile now that I've got the entire standard library in one go? So, if you attended earlier talks, you would have seen these numbers put up on the screen. And basically, the message is it's fast. And it's not a problem. You're still going to get a speed up. And in the paper there, 2412, that's where those numbers come from. There's more details there. And this is their summary. Somewhere between 5 and 25, who cares? If it's 5 times faster, that's good. And that's for the whole standard library in one go. Okay, so this is well along the way. It's basically got one more poll, it's got plenary poll, library working group has to look at the words and say that they're okay, but it's looking really good. So I don't see, and there's high motivation. People really want to see this facility. I think Bjarne talked about it pretty passionately on Monday. Okay, number 2, input-output, or number 3. So input-output is also a fundamental thing that's basically used in every single program, which is why we'll spend a little bit of time on this. We probably will not spend much time on Spanstream, just because, from a timing point of view, we're not going to get through anything else. So what happens here? Anybody got an idea? Compilation error. Well, not really. If you were using an earlier version of FMT, or you were using the standard as originally written in C++20, this would have been a runtime error. The error here, of course, is that 42 is not a string parameter, so there's a mismatch between the specifier and the parameter that's going to format. And so the fact of the matter is, this can be determined at compile time now, and it should be determined at compile time now, and it is determined at compile time now. There's only one problem with this. Putting this in C++23 would effectively break the ABI, the API of format. So this is an example of one of the bug fixes, and it is also something that was a little unusual because this bug fix came fairly late in the cycle. It was well after C++20 shipped that we made the decision to backport this change. There were a number of other reasons why. There were other issues with the format API and what it was causing in terms of the implementations. And I really recommend go see Charles Bartow's talk from Microsoft. His talk was on Thursday. Watch it online if you're really interested in the details, because he's actually implemented or worked on implementing this stuff. But anyway, this is a great improvement. When we put this in 20, I wanted it this way, but at the time we didn't think it could be done, so now it can be done. So it's good. Okay. And I think I said all of this. See Charles's talk. He goes into it in gory detail. Okay. So this is a new facility. In C++20, really all we gave you was format, right? So, you get format specifiers, you get a list of arguments, and you can make a string. So the only problem with that, of course, is that if you want to do console I/O, well, now you have to turn around and use I/O streams to do that. But we're going to eliminate the need now. So we're going to have a new header called print, and we're going to adopt the facility which looks exactly like the format API and allow you to put formatted information directly into the console, into a file. There's also going to be a print line version of it, or print ln version of it. You don't really need print ln because you can always say \n. And there's another big thing that I'm not really going to talk much about, but this also helps with Unicode. The standard has been trying very diligently to get C++ into a world where it's more compatible with Unicode and Unicode strings and so forth. And this is one of the things that's going to help. Okay. So for output, this kind of eliminates the need for IO streams. And after you've started using FMT for a significant amount of time, I think you'll be rather happy with that. Not having to use IO streams is nice. That way, at least your code base can be consistent. Okay, so this stuff is still in somewhat of a final design review, but I think it's no problem. It'll get done and get into 23. So here's just something interesting. If you look at that middle row in the table, you might notice that basically it's faster than C, which is cool. And the reason is that, you know, C++ can do a little more and doesn't have to live with the printf, variadic, parameters. We can do more compile time than C can, and we can nicely inline this stuff, and it's super fast. And it's way faster than IO streams, which is also not much of a surprise. So this is a compelling reason to use this stuff, if not for the other benefits associated with how the API works. Okay. Okay, so there's some resources on what it's about. Sorry, my clicker is giving me trouble here. Okay, so here's another little tidbit, and it's unfortunate this is not going to be in a completely clean state in C++23, but if you start using the standard library formatting, a number of things actually got format specializations so that they could work with format, but a number of things did not. So like error code, thread ID, those are probably ones you would use commonly. Those are going to get into 23. The other ones like shared pointer and file system and complex, it doesn't look like are going to make it. Oop. Okay. So this is a piece of code which I've really wanted to have in C++ for more than a decade. I think at the very first BoostCon, we actually were playing with trying to do something along these lines. But basically what you're seeing on the screen there is printing a range in one line of code. It's cool. It's very nice. Very, very nice. This thing, I don't know if it's going to get in. And the reason is it's complicated. Imagine if you didn't have a vector of a uniform thing, but you had a vector of variance, or you had a vector of any, or you had, so there's a number of complications, or you had a vector of vector, or you had a vector of maps, or, so you can imagine that it gets a little bit more complicated than what I'm showing here on the slide. But I'm hopeful that if we don't get it in 23, we should certainly get it in 26. But interoperation with ranges is a very nice thing. FMT today has FMT join, which allows you to write the code that you're seeing on the screen here. Okay. A couple words about Spanstream. Basically, even though we're, doing major upgrades to format, we're still bringing streams along. And there's actually one very specific reason why we're doing this particular change. So in the very oldest version of string streams, you had a facility that is not offered in the current string stream implementations. Specifically, you could supply a buffer of your own making, and that feature never made it into string streams. And the other thing that's happened is in C++20 we got span. Who doesn't know anything about span? All right, span's good. So you want to basically be able to supply a buffer, and you also want to be able to get access to the buffer in a very efficient way. And so that's what this facility basically does. And I'm not going to go through span because you guys already know it. So You're going to include Spanstream, and then you're going to be able to, on an input stream, supply your own buffer, and also on an output stream, you'll be able to, or you'll also be able to get into the buffer and get a span out of the buffer. So, and then you can do ranges algorithms on your string stream, which is cool. Okay. So, ranges. Who's using ranges? Okay, good. Quite a lot. So, ranges in C++20 is good, but it had problems. Mistakes were made. So this is another area where we've actually broken a number of things as they were specified in C++20. And it's interesting move, change for the committee to do that. So we're going to fix issues in 23, but some of those will be backported. You're going to get new range algorithms, and you're going to get new range adapters and views. There's a number of other facilities that are really important too, like ranges 2, which is basically the ability to make a collection from a range. There was another observation that Walter Brown, who was in the room earlier today, made to the committee, which is, if people could actually write, pipe operators for their own custom views, then maybe there wouldn't be quite so much pressure to put them all in the standard, which we're never really going to be able to put them all in the standard anyway. But somehow we didn't get the pipe operator customization ability in C++20. So that's going to be in C++23. And actually, I have a reference at the end, but there was a good talk about that yesterday as well. Okay. So let's look at some. Well, let's go back and let's review ranges for 30 seconds. So at the highest level, these are what ranges are, right? We have ranges, which are essentially something that can be iterated over. They usually have a begin and end, or they have a begin and end. Range algorithms, which is an algorithm that takes a range, and a view. Oop, sorry, something behind me there. And a view, which is something that's lazy and cheap. So pretty much my description. But anyway, no, sorry, to copy, that's, cheap to copy. Bad joke in the late afternoon, it's not working. All right, so range adapters are things that make a range into a view, and let's look at, we'll see some examples of this a little later if I can go through the slides in the right order. But let's look at a range algorithm, right? Here's the fundamental difference, right? Sort, you used to always have to call it begin end, and sort, there it is. Just put in your range and go to town. So nice, so clean. It's really the way you wanted to be able to write your STL code for the longest time. Okay, so in 23, you're getting a series of new algorithms, shift left and shift right for ranges. Now, you might recognize those from C++20 because you got STL versions of shift right and left in 20, but the paper to get the ranges version missed the boat, or missed the train, so those are coming in 23. Fold left and fold right starts with end with, iota, and find last. Maybe find last. We'll see about that one. So what is fold? Fold is a generalization of accumulate. If you've studied the 20 ranges very carefully, you probably recognize there were no numeric algorithms in C++20. So fold is a generalization. It takes an algorithm and an optional initial value in addition to the range. And then it's going to execute, a function like, summing, for example. So there's an example of what it looks like. Fold left, fold right, You can go different directions. There's this idea of first and last. So if you don't want to actually, or you don't actually want to have an initial value, you don't need to pass an initial value. And in that case, there's a bug on this slide actually. This slide should say fold left first. Yeah. So that's what the first and the last are, the first of the range and the last of the range. So that's cool. Something we needed. There's shift left, shift right. And basically, these are, again, same as C++20, but now the ranges version of it. So you've got, your range, and you have a shift left, which does something very interesting. And then if you call erase, you'll see. Now, what's interesting about these shift right and left is they don't actually change the size of the range, the underlying range. So if you want to use shift left to, in fact, change the size of the range, you have to use erase and so on and so forth. Okay. All right. So I'm thinking I'm going to skip over starts with and end with. That's pretty straightforward. Views and adapters. So this is the other big piece of C++20. And the things that you see there on the screen are some of the additions for views and adapters that we're going to get. And some of these things are really interesting. But let's go back and let's look at a little bit of C++20 code here. Just to remind ourselves of how views and adapters work. So at the top of this, you have your range. The predicate is even, which does a simple calculation. And the third line there is actually constructing an adapter on the stack and tying it to your vector range. Now, there's no calculation done at line 3 where we create that thing called evens, right? We have to iterate over it to actually go through the range. And so that was what I was saying before about, views are cheap to copy and so forth. That got more complicated in C++23 as well, because there is actually a recognition that there can be views that actually will have ownership over some element. That's another thing we normally think about with views, is that views don't own anything, but sometimes they might need to. Those are corner cases mostly, but they are hard corner cases. So this bottom part then is just, the same thing as on top basically, but actually using the view. So you see the words there, right? Views : filter, that's actually the adapter, and then filter _ view is actually the view. These things are very interchangeable. You see the pipe syntax on line 3 as well. And so that's where today, if you write your own view, you won't be able to do the pipe syntax with other C++ ranges, unfortunately, or views. Okay. So a lot was broken in C++20, but it was a lot of work to put ranges in. The one ranges paper was something like 400 pages of wording, more than that probably. It was a lot of work. But iStreamView is getting corrected. Now, if you haven't used any of these, none of your code, you won't even notice, you won't even know. So, you can just ignore my talk from 2019, when I had a split view thing, because that one definitely changed a lot. So split view was problematic especially if you want to do things with strings, which is really kind of the motivating use case. So it became clear that it really wasn't right. So not only did we change the API to it, but we just changed the function completely. Now we left the capability that was in C++20 there, we just renamed it lazy split view. So you can still do what we had before. I'm not going to go into all the details of this, but if you haven't used these things yet, then when you use them, they'll all be good and right. So you won't even have noticed that we broke you before we broke you. All right. So another proposal that's on the table also seems like a pretty good idea, because if you've noticed, there aren't any like parallel ranges algorithms, for example. So there's a huge number of algorithms to actually, put together, and I'm not sure there's ever going to be parallel algorithms that operate on ranges. I think there's some issues there, perhaps. So, bottom line is, there's a bright idea that says, hey, at least we should be able to interoperate with the old school algorithms, right? Wouldn't it be nice to be able to compose those into our ranges algorithms? And so there's a proposal for this facility, and that one's still in the design group, and hopefully we'll make it through. All right, so there's all sorts of new fun features for taking apart views in different ways, sliding down, chunking up, so on and so forth. I'm not going to go through the rest of them, but there's some examples here, and you can take a look at those. All right. I do want to spend a minute on zip. The zip paper actually includes zip and zip transform. Zip transform allows you to apply a transformation as you're putting ranges together. One of the very interesting things about this, actually, this paper is fascinating to look at the design of this utility. It's some really interesting C++ code. But basically, you're going to try and do something like this, where you have, n number of ranges, and you want to combine them all into one. So in the first example of the print there, basically it's zipping together the two vectors, and putting it out, printing it out as it goes, for each element. This may be depending on some code that you're not going to get the print part. The zip transform case is actually multiplying the elements from each of the two vectors that it's putting together. Now, in this particular set of examples here, we're only doing 2 vectors, but we can do n. We can do as many as you'd like to zip together, because it then looks basically like a tuple. So this is a very sophisticated facility. If you can imagine the application in something like FlatMap, FlatMap operates on the idea of 2 underlying collections where the keys and the values are actually in separate collections. Normally that's like an STD vector. And so when you want to get those out, you want to get them out as pairs, you zip those 2 collections together, and that's how you can get them out in a consistent fashion. Okay. Ranges 2. That's it. Enough said. Okay. Enough on ranges. As I say, I could have spent the whole hour on that. I skipped over a lot of details, but undoubtedly there will be, ranges 23 talk in your future sometime, where we can actually go through them all. Okay, now I want to talk about, constexpr all the things, and if const eval just a little bit. So everything's getting more constexpr all the time. So you can do more stuff at compile time. These things are what they are. Let me talk about a couple of them though. CMath, that's interesting, right? That's a little bit complicated because not every math function that you can actually do in the CMath library is being made const eval, or being made constexpr. But a large number of the normal ones are being made constexpr. So you'll have to look at the details on that if you're trying to do some mathematics that you want to resolve completely at compile time. To chars and from chars. So those are new facilities since 17 that allow you to go to and from characters in a very performant fashion. You'll be able to do this for integral types, not for floating point types at compile time. So there's a fair number of use cases that those things will come in very handy. I will mention if const eval because who uses if constexpr in places? Yeah, it's super popular, isn't it? It's a cool thing. So if const eval is the cousin of if constexpr, and it allows you to say you must be able to evaluate this at compile time. So that's another nice facility, and that is the one language facility that's coming. Okay, so there's a few more things there in the slides. All right, I said I was mostly going to skip containers. I'm going to skip that stuff, and now let's see. What do we want to talk about? We want to talk about expected, stack trace. Byte swap is small. That's a one-liner, but monadic optional. I heard one optional. What was in the back? Expected. Okay, we'll do those two. Hopefully we'll have time for that. Okay, so monadic optional. This is a simple thing, really. It just adds 3 functions. But it allows you to write things in a functional style. It's a very nice, clean way of being able to do things with optional. So, here's the example from the paper, actually, where you've got an optional string value, and then you apply a function. And if that succeeds, then you're going to apply a transform, and you're ultimately going to get a result on the back end. So it allows this very nice compositional style, functional style. I'm probably going to set some people off here. So this one is basically in. It's already all done and voted into the standard library. If you want these capabilities, I recommend Cybrand's library. It seems to be very good. So expected then is actually sort of the cousin of optional, right? Optional, you're saying I'm going to return something, maybe. And in this case, you're saying I'm going to return something or I'm going to return an error. There's one interesting side case here, though, and that is, what do you do if you actually have a function that wants to return a void? That's a valid case, but you also might need to return an error. So one of the things that expected does that optional does not do is it has the ability to have a void overload, so you can return a value, not a value as it were, but then you'll know whether you actually had success or if you got an error. So the error code type is your own custom type, or it can be a string or whatever you want it to be. Here's a little example of trying to, parse some, time string and take something that uses exceptions and basically turn it into an expected. So what you can see here on about the 5th line there, that time expected construction is using the expected. The first parameter there is the time type, and the error type is a string. So in this case, what I'm basically doing here is I'm doing the try catch. If there's an exception because the string is ill-formed, then I just make the unexpected case using the exception context. And so what you'll see if you run this code is something like this. That second string is obviously not a well-formed time, and so it basically comes back with a terrible error, which I don't want to own up to. Sorry, is there a question over here? Yeah.
Will expected have the same monadic operators on it that are being added to optional?
Right. The answer is it does not in the current paper. I have a paper that I've drafted, and I just need to finish it, and I think it will go in. I think this is something that's so obvious that LEWG will be able to handle it, even though they have a lot on their plate between now and the end of the year. And in Ball, I have warned Bryce about this. So he knows that's coming. So yes, or we failed. One of the two. Okay. All right, so we have 15 minutes left currently. So we probably have a little bit more time. Does anybody have any other questions? Yes?
Yeah, any chance we'll have a monad concept?
I have not seen anything like that. I don't know, in Ball, have you seen anything? I don't remember seeing anything like that being proposed at the moment. So, probably not. Go ahead.
Oh, one more thing. I just noticed that with the expected, it seems to me that if the template arguments were the other way around, then they could be curried more easily. In case you have an expected with an error type that's known.
Yeah, I don't know. Okay.
I can, Jeff?
Yes.
Yeah,
Thank you.
the opposite way around in C++ to Haskell, but C++ doesn't have to carry on the first argument, so.
Yeah. Oh, there you go.
I think on your optional slide, the monadic examples you had, I think you had an error. You're passing S2I to and then, and I think the function passed to and then needs to return an optional.
Possibly. Let's see.
Yeah, this one. I think you just passed S. You would just use transform to pass S2I, I think.
Possibly. I mean, I got to tell you, this is right out of the paper. I didn't actually invent this one. Not saying it's not my mistake, but Cybrand was the one who wrote the example. But thank you. I'll look at that and make sure that's correct or not. Okay. Any other questions? So we got 10 minutes left. Is there something? Why don't we talk about stacktrace? I think that's a good one. Okay. So who's used Boost stacktrace? Half dozen hands. Okay. So obviously this is a facility that has been missing from C++ forever. And obviously it's something that's very helpful in certain circumstances. Certainly, if you're in a place in code where you're going to do an assert, maybe you're going to throw an exception in some particular place, you might actually want to know what the path of execution that got you there actually is. This one was one of the ones that was in the list of things to go into C++ 20. It's already been added into the working paper. So this one is almost certainly going to be in 23. So it's based on Boost stacktrace. There's a lot of complicated details here because it's going to be dependent on things like your compilation mode, what your compiler actually gives you back in the data. So there's a lot of, we're not saying exactly what this does, except for it's going to give you something about the stack of execution. And we're counting basically on vendors to do the right thing here, given the context. It might be the case that, when you don't have any debug symbols or anything like that, it can't give you any real context. And we're expecting that you'll have control over those options as you go. So, this is the canonical look at it. Essentially, you construct a stack trace object, and that's it. You have the information. There's some additional API here, which allows you to actually, get information about, the details of each entry, so you can iterate over that and so forth. And there's a toString in addition to the IOStream operators. Okay. All right. Anyone excited about C++ 23 yet? Woo! All right. Yeah, it's definitely going to be smaller, and definitely I think it's going to be good, though. It's going to wrap up a lot of C++ 20 things. And I'm surely some of those things that were at the top of the list, there probably will be a few of those things to get in as well. So if there's not more questions, we still have a few more minutes, so we can
have a few questions from online audience.
Oh, okay.
So the first question is, are we ever going to get a secure string, just for example, a string that wipes out a storage during relocations and in the structure, especially for the small string buffer?
I am not aware of any proposals for that. There was some kind of proposal for doing that, and I don't remember the details on it, but I don't think there's nothing in flight for 23, certainly, and I don't think I know of anything in flight for 26 either.
Thank you. And one more question from Alexander Bocherikov. What is the issue with parallel range algorithms?
What is the issue with parallel range algorithms? Well, it's going to depend, I think, on the details of the range. So the parallel algorithms have to know something about the range to parallelize, and it's not necessarily clear. So it's not, you would probably have to have a bidirectional range at a minimum, something that supports bidirectional to parallelize it. I also just have not seen anybody actually propose it. And I remember talking to somebody, I don't remember who it was now, and they expressed concerns that it might not be so easy to do. It seems like it should be possible, but it would be much more limited than you can do with a lot of other things. If we get the ability to go back to to interoperate with the standard STL algorithms more cleanly, it probably won't be worth the time to do anyway. Okay.
One more question. Will we have sprint and fprint in addition to print?
So sprint is string print, which is basically format, right? Sorry, what was the other one?
And fprint.
Fprint. So yeah, let me go back to the slide. So it might have gone by a little quick in this case. Sorry. So if you stare carefully at this slide, you'll notice about midway down, there's a fopen. And that's a file handle that's being passed to the print. So there's an overload that takes a file handle. There's also overloads for streams. So you could put, a file stream or a string stream as the output to the print. So it's actually quite flexible, and I think that's going to cover all of the things that the person who was asking the question wanted. We got one over here.
Yeah, you mentioned that views are mostly non-owning, but can you provide an example of when that's not the case?
Yeah, so what happens, when you have a single view returned from something that is a range that, for example, has shared pointers. So now you've returned a single view that holds a shared pointer. And this violates the semantic constraints that were originally there for views because the destruction time is non-deterministic now, right? It's not order 1 anymore, necessarily. It might be, might not be. So there's a little bit of relaxation going on there now because it's a valuable thing to be able to do. It's really hard. It's really hard to balance all that. Yeah.
I wanted to add, there's also a view called owning view,
Yeah.
which you can give like an R value vector, and it owns that vector.
That's,
and
yep.
it counts now. And I think it's in C++20. I think that was part of a defect report.
It was part of the defect report. Yep. Yep. Thank you. Arthur.
Another question about print as long as it's on the screen.
Yeah.
So there's overloads of print that take file stars and that take O streams. And so does the print header drag in all that stuff, or are these somehow templated on some O stream-ish concept? Or is this really dragging in not just the new thing, but every single old thing in the world as well?
I'm guessing it's dragging everything in, but that's okay because you're just going to say import std and it's all going to be good, right? But actually, it's a valid point, right? Like, is that file star going to be in import std? I don't think so. That's a C thing. Yeah. Hey, Dave.
Hey, Jeff. So it's great to see print. That was in Swift version 1.
No doubt.
Because like it's really important.
Yeah.
There's one thing I think you're missing.
What's that?
Everything should be printable.
Yes.
Everything. Like,
yes.
You don't have to do anything. You don't have to opt in. There should be a way to print.
That would be nice. Of course, you have to write a specialization for your own types now, currently. I don't know of a way around that with design.
You could use magic get and just like print each member. And it's recursive.
Yeah.
So that would be an unspecialized one. And that's like really crucial for that. Like, I'm just experimenting. I've got, I need printf debugging here. What is it? Don't make me specialize.
I'm really looking forward to the paper, Dave.
Yeah.
I definitely would help you with it.
Okay. You can help me by writing it and all.
Dave's saying I could help him by writing it. So there you go. All right.
One more question from internet.
Okay.
Any idea when we might get Herb's metaclasses, unified error handling, or is /s?
Yeah, that's not going to be in C++23 for sure. I think Herb said himself in his talk earlier this week that he's been kind of waiting until we can get back face-to-face, which will probably be June of next year. And so hopefully they'll resume work on that for 26. I don't spend a lot of time on the language side of things, or nearly as much, so, but that's my understanding of the status of that. Yeah.
And one more question here
from
David Knott. According to the proposal, stacktrace uses allocator as its default allocator. Does that really make sense given that it is often used in crash or exception context?
Yeah, it could be a problem, but I think you're going to mostly use it during debug. And of course, maybe you're going to remove it in production. Obviously this is a long, old conversation about, exceptions, whether or not you can allocate, for example, during that context. And I think it just depends on what the exception, for example, actually is. So, it's an interesting question. I'm not sure I have a great answer. Okay, thank you.